Okay, guys, so we're going to go through trigonometry chapter 10 and a bit of 11.1 and 11.2. So I'm trying to make this as concise as possible. So I might not be able to go through many examples. Lah. So the examples you all have to go through. I can just go through what is the basic, what is needed. Okay, so let's go through chapter 10. Okay. So under chapter 10, first we are going to go through trigonometric functions of angles, okay, or ratio lah, okay, trigonometric ratio. So 10.1 is about Trigo ratio and maybe a bit of special angles also lah, okay, special angles. Okay, so now the basic thing that you have learned in Sec 1 and 2, okay, they are considered as sine theta, cosine theta, and tangent theta. These are called trigo ratios. They are called ratios because sine of an angle is equal to the ratio of opposite over hypotenuse. Adjacent over hypotenuse is for cosine theta. Tangent theta is O over A. And all these are fundamentals from your right angle triangle. So if this is your theta, okay, then this becomes your opposite side because it's opposite to your right angle. Opposite to your right angle is your H, and the remaining is your adjacent. Okay, so this is a basic thing that you have learned. Okay, but apart from here, you also need to know, because we'll be also dealing with radians very shortly. Okay, so you have learned this as well. You have learned this on radian. So when we talk about radian, okay, you need to do the conversion very basically. So it's 180 degrees gives you pi radian. This is a basic thing that you should know, the conversion lah. Even if you forget everything else, you should remember this lah. Okay, so examples, like for example, if I talk about 90, all these are special angles, so pi over 2. If I talk about 360 degrees, then it's 2 pi. If I talk about 45, then it's pi over 4. Then what else? 60, pi over 3 radian. Then 30 is pi over 6 radian. So all these are your conversions. Conversion from degree to radian. This one's very important before we begin. So this will form your fundamentals. Okay. Now, besides this, then we also need to know about special angles. Okay, so when we talk about special angles, then there are only two types of triangles that should come to your mind lah. So first is a square. So I cut the square. I cut the square into half. Okay, so this becomes 1, this becomes 1. This is right angle, this is 45 degrees. So that will give way to this triangle here. 1, 1. So this one becomes square root 2. According to Pythagoras theorem, 1 plus 1 whole thing square root. Okay. Now, another special, okay, is your equilateral triangle. All the three sides are the same. I will cut this into half again. When I cut this into half, this will become 30 degrees. This one will become 60 because it's equilateral, right? All 60, right? So cut into half. This becomes 90. Equilateral triangle, all the sides must be the same. So we take this as 2, 2, and this one become 1. If this is 2 and 1, then this becomes square root 3. That's why this gives rise to another special type of triangle where you have this as 60 degrees, this is 30 degrees, this is 1, this is square root 3, this is 2. So if you ask me, this is important. Okay, so from here you can calculate all your different um, cosine, sine, cosine, tangent, all the special angles. Okay, so if you want to remember, then I can just draw a table for you lah. Okay, so all these are the special angles and ratio. So let's draw. Okay, so this is your sine theta, cosine theta, and tangent theta. So you have 30 degrees first, or this is considered as pi over 6. 6, we'll take 45 first. Okay, 45 pi over 4 in terms of radian, 60 degrees. This is pi over 3. So if I were to fill up, okay, then this is half, this is half, okay. Sine tangent 45 is always 1, okay. Square root 3 over 2 cosine, and this one will be square root 3 over 2 also. These two will be the same. It's either you take it as 1 over square root 2, or this is the same as writing square root 2 over 2. It's because we do rationalizing lah. And this one is 1 over square root 3. So equal to square root 3 over 3. And this is square root 3. So this is important. A lot of questions will be asked based on this lah. So whenever they ask you to evaluate without using calculator, this should come to your mind already. If you want, you can draw this table at the start of your exam so that you have one less thing to worry about. Okay, up to you to whether to memorize or to do like what I've done like here. I like to go through the basics. So I won't even draw this. I'll just draw the two triangles is good enough for me. Okay. Yeah. So besides this, then they would also go about with another section. this section is talking about again the right angle, but this time, you know, this is theta. This is 90 degrees. So what is this? One hundred 80 minus 90 minus theta. So this gives me 90 minus theta. So based on this, I can come up with the following ratios. So I can talk about sine 90 minus theta. Okay, so 90 minus theta is this one. Okay, which will be the same as, the ratio will be the same as what? Cosine theta. You can check for yourself. Okay, maybe I can give a number if you want. Okay, so let's take this as 3, 4, and this is 5. So sine 90 is what, guys? Sorry, sine 90 minus theta. So it's O over H. Now, can you tell me what will be the answer for cosine theta? Sorry, 90 minus theta. My O is wrong, sorry. It should be 4. Yeah, 4 over 5. This is your O, this is your H. Now, for this, it's 4 over 5 also, but this time this is A and this is H. So you can see that both are the same. Therefore, the conclusion is that sine 90 minus theta is equal to cosine theta. This one is good if you can memorize. If you can't, then you should just draw this triangle out. Okay. So this is important. It's only one of the equations. So there's a few more. So I'll just write down those as well. Cosine 90 minus theta is the same as writing sine theta. And tangent 90 minus theta is the same as writing 1 over tangent theta, or now as you know is cotangent theta lah. Okay, so based on this, they will always like to ask you questions. So this is another important portion to remember. Okay. Next, we'll be going on to the reference angle, the quadrant, and functions as well. So we'll just take it as reference angle, okay, and quadrants. Okay, so in terms of reference angle, what we'll be doing is we'll be focusing on this thing here. You have to go always clockwise. So this is your 0 degrees, this is your 90 degrees, 180, 270, and this is called 360. Okay, so you must always go clockwise. So this is called your first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, and must always go what? Sorry, anti-clockwise. Anti-clockwise. Okay, so If in the first quadrant, let me use a different color. If it's in the first quadrant, then this is your theta. Okay. If it's second quadrant, then you draw your right angle here. This time your theta is from here to here. This is your theta. This is your alpha. And the alpha is your reference angle. Okay, can? This is for second quadrant. If you go to third quadrant, you draw the triangle here. Okay. And your angle is until here. And this is your alpha. Okay. If it's fourth quadrant, it's all the way until here. This is your theta. This is your alpha. So you must know how to draw your triangle first. That's the most important part. Okay. So a lot of them ask me, or when you come across this one, like cosine 330. So they ask you to convert to something that you know of. Okay, can you evaluate this without using calculator? You can be dumbfounded. But actually the 330 is your theta. So can you see the theta is 330? So this belongs to cosine 30 degrees, correct or not? The alpha, this is your alpha here. So it would give you the same answer. It will give you the same answer. Now, this one depends on which quadrant it belongs to. Which quadrant? So if you take notice, this is in which quadrant, guys? Fourth quadrant. Okay. Fourth quadrant, cosine will be what? Positive. So it's positive lah. Okay. Can? And from here, you know that if you draw your triangle out, you get square root 3/2. So this is the link that we are trying to form. So these are the connections you must make. Okay. Basic connections. Okay. So if you notice, what I've been drawing is drawing this radius, the R here, that goes around. So it forms a unit circle. So the radius is always R. The radius is always R. Okay. So and this thing here is also R. Okay. So it's always R, no matter where it is, because it's a unit circle. Okay. Can? Okay. So this being done, now we go more in depth into the quadrant itself. So in the first quadrant, sine, cosine, tangent, all are positive. Second quadrant, only sine theta is positive. Cosine theta and tangent theta are negative. Third quadrant, sine theta is negative, cosine theta is negative, but tangent theta is positive. Fourth quadrant, sine theta is negative, cosine theta is positive, and tangent theta is negative too. Okay, can you follow so far? Okay, no answer means no questions, huh? Okay. Okay, let's do one example to give you a feel of what it is. So what I'm going to do is try it 6. Your given sine theta is negative 5 over 13, and you're given this as well. You're asked to evaluate and tangent theta. Okay, so how do you go about doing this? First, I draw my quadrant. Sine can be only negative in two blocks, which is either second quadrant or third quadrant. But since you're given this, it should be in your third quadrant. So this is O. O is 5. O is 5. 13 is here. And you know that because it's over here, this is negative 5. The hypotenuse is always 13, which is your radius, which is always positive. So then this will become naturally 12. So I put in a negative here because it belongs to the other side of the x-axis. So it's negative also. So now they ask you for cosine. So what is cosine theta? A over h. What is A? Negative 12. H is 13. That's it. Done. Simple. Remember, they are not asking you for angle. Remember the difference. Cosine theta will give me ratio versus theta. Theta is just an angle. Note the difference before you do anything. Okay, don't go and solve for theta, which is what most students will do. This one is O over A. O is this one. Your A is here. So it's 5 over 12. Because the negative will cancel out each other. Okay, so that's it. Okay. So far, if you notice, for the quadrants, we have been going through positive angles. Okay, for negative angles, you have to go clockwise direction. The quadrants all will remain the same, but it's just that the way you move will be different now. So I'll have a negative angle over here. So now I'm moving my directions like this. Hope you can see, it's this way. So going this way, you know that cosine sine of a negative angle, what impact will it have? If fourth quadrant, what is positive, guys? Okay, thanks for your response. Okay, Chan? So if you notice, these two is negative. Sine theta and tangent theta is negative. Cosine is positive. Okay. Of course, if you go for all the other angles, it will still be the same lah. So if I go through, maybe I go through another one more. What if I go over here? So from here to here is my negative theta. This is your alpha here. Okay, so again the same thing. So this one you're talking about negative angle. Okay, so if you're in this quadrant, only tangent theta is positive. Sine or cosine, okay, will give me negative. The ratio will give me negative lah. Can? Okay, so then we move on to what about the reciprocal? Okay, so this section is about cosecant, secant, and cotangent. So if you talk about cosecant, or we take it as cosine, okay, cosecant theta is actually 1 over sine theta, okay, where sine theta cannot be equal to 0 lah. If it's equal to 0, then it doesn't make any sense. It's undefined. So same for secant theta, it is 1 over cosine theta, and same for cotangent theta is 1 over tangent theta. So with this, they can also ask you to find questions. They can give you questions that involve cosecant, secant, kind of values, and then ask you to solve. Maybe you can do one. Okay, so let's do one question. Without calculator, maybe cotangent. We do cotangent 4 pi over 3. No, what is it? Oh, sorry, it's cotangent 330. So this is from your example 9. So if you're given cotangent 330 and you are asked to evaluate this, so what I will do is first I'll bring it down to tangent first. So tangent 330, and 330 is in which quadrant? It's in this quadrant, correct or not? Where this is 30 degrees. You already know that it will become tangent 30, because this is 330. So alpha is 30, your basic angle. But because it is in the fourth quadrant, only cosine is positive. So this one must be negative. That's the only thing that you need to do over here. Then the next thing is what? Draw the triangle. This is 30. This is 1. This is 2. This is square root 3. So it's O over H, which is 1 over 1 over square root 3 minus. So this will become minus square root 3. Okay. Quite a bit of time, but 30 minutes just for chapter 10.1 only. We have only covered 10.1. Okay. Now let's move on. Now is all the Trigo graph. Now we are going to talk about graph. So 10.2 graphs of Trigo function. Okay, so the first one, we're going to take a look at sine graph. Okay, we're going to look at all the things about sine graph. So okay, so important points to take note of. The maximum value is 1, the minimum value is -1. And this thing here is called as your axis of curve. It will play a very important role. You should know by now. Okay. And what else do you know? You can put in all the values. So this one will be 90 degrees, 180 degrees, 270 degrees, 360 degrees. So one complete cycle is from here to here. Or one complete revolution. And this is called as period. Okay. So important things to know. All these stuff are the most important things to know for the y equal to sine theta curve. This is your y, this is your theta. Okay, basic curve, but you need to know a lot of things. Okay, like your amplitude. So if they ask you what's the amplitude, amplitude is 1. So this is always within the boundaries. This is the boundary, very important. Second, the period, it's always 360 or 2 pi. Okay, what else? We should also know that maximum, minimum, already said. Okay, so um, when sine x is equal to 0, what are the values of theta? It's 0, 180, and 360. So I'm talking about this, and this values. When sine x is equal to 1, then theta is equal to 90 degrees. There's only one value here. And another important is x equal to -1, theta is equal to 270. All these should be at the back of your mind. Okay, this is for sine curve. Now, how about cosine curve? Important points. This is 1, this is -1. Okay, then you know what should these values be. So these are all the important points. Okay, so this is 90, This is 180, 270, 360. Again, this is one cycle. Okay. Of course, it goes without saying that cosine theta also falls within the boundary of 1 and -1. The period for this one is always 360 or 2 pi. That's the next one. Then you should know what is cosine theta equal to 0, when cosine theta equal to 1, cosine theta equal to -1. All these are the important points. So theta here will be 90 and 270 over here and over here. So when is it equal to 0? When is it equal to 1? It's equal to 1 at 2 points. Theta equal to 0 or 360. And when is it equal to -1? At 180 degrees. Okay. This is all there is. This is a basic curve lah. Okay. Let's move on. Then comes your tangent. So your tangent graph is unique. Okay, because okay, let's put in all the important points. So this is 360. Okay, this is 180. This is 270. This is 90. Okay, and you have another point here, 45, but it just means that this is always equal to 1 lah. Okay, now unlike cosine and unlike sine and cosine, you don't have a limit here. So tangent is infinity to -infinity. It's not bound by -1 and 1. So that's something different. And the period is also different. Period means one cycle. So the period here is just pi only. So if you notice, I can repeat the pattern. I can repeat the pattern from here to here. This is one cycle. So I can just take this block. Okay, I'll erase this off shortly. Or maybe I use a spotlight. Okay, I'll just take note. So this one, okay, is one block. And this is another block. Can you see this? It's the same. This block and this block. So there are two cycles within 360 here. So this is the first cycle. So we just take it as pi only. Understand? Okay. What else? Another important thing is that just basically tangent. When is tangent theta equal to 1? Okay. When tangent theta is equal to 1, it's theta equal to 45 and 225. When is tangent theta equal to 0? This is easy. You have like 0, 180, 360. 0, 180, 360. So when is it negative? It's negative at theta equal to 135 and 315. So this is your 135. You go further, this is your 315. Hope you understand. Okay. Of course, sine theta, cosine theta also have amplitude, which is only one. But here got amplitude cannot be defined. That's something unique. So tangent theta is slightly different from all the other two curves. And the main reason for this is tangent theta is equal to sine theta over cosine theta. Okay. So if you notice, because of these unique features here, that tangent theta over cosine theta is equal to tangent theta is equal to sine theta over cosine theta. If you notice, at 90 and 270, 90 and 270, your x is becoming 0. Can you see or not? Okay, it's becoming 0. So when it comes close to 0, when you have like 1 over, because sine 90 is 1, okay, sine 90 is 1, and this one is getting close to 0, like 0.00001, example. It will give you a very large number. That's why you have the asymptote at the 90, and you can see that it increases exponentially. So this is the, the, the fundamentals behind it, the deeper understanding. Okay. Yeah, I think I covered the part already, but we just need to do maybe a few examples to showcase how this would affect us in terms of when drawing graph. Okay, so maybe we can take a look at sine theta first. Okay, so you have y equal to a sine bx plus c. I think this is a common type of thing that you have seen. So the a here refers to amplitude. Amplitude is the highest point or lowest point to the resting point. Okay. Now, B refers to period. How many cycles? So a simple gauge is that when B is greater than 1, that means to say you have more cycles within 360. If you have B less than 1, I'm not talking about negative, I'm talking about like half, 1/4, okay? So examples like that. So examples like that, that will mean that you have less, you don't have a full cycle, okay? Do not have a full cycle within 360. So you can think of it like compression and expansion, okay, or being stretched. Okay, so B less than 1 is being stretched, whereas B greater than 1 will be compressed. So you get more cycles within the same 360. Okay, this one is usually your axis of curve. Because you're moving away from your rest point. Initially, your rest point is 0, y equal to 0. But your rest point can be changed when you manipulate your C. So that will become your axis, okay, of curve. So let's do one example. Okay, we have, okay, let me choose this. Fx equal to 3 cos 2x plus 5. Okay, the questions they might ask you: number one, state amplitude. Part two, find minimum, maximum values of fx. Then they might ask you to sketch also, sketch the graph. Okay, so how do we do this? Amplitude refers to this number here. So you can straight away say that amplitude is equal to 3. Solve. How about minimum maximum value? Okay, the minimum maximum value depends on fx equal to 3 cos 2x plus 5. This one is the same as writing between -1 and 1. So one of the value you can put it as 3 negative 1 plus 5. Another one is 3 1 plus 5. So over here you get maximum value. Here you get minimum value. So this is -3 plus 5 is 2. This one will be 8. Okay, this will help you to figure out how to draw the curve. And of course, you should know that the middle point is the 5. So 5 is being pushed upwards. So from 0 now is being pushed upwards. Now, other than that, you must also take note when you draw your curve, which is part 3. This one has 2 cycles within 360. That's the meaning of it. If you have 2x, it means I will have 2 waves, 2 cosine waves within 360. Okay, let's draw that out. Okay, so first thing first, what I'll do is I can either draw the cosine 2x first. Okay, you can do this first if you want. So your normal cosine is like that, 360. This is 180. This one is 90. This is your normal cosine x. But now it's cosine 2x. So you should have 2 of those. So this is your 360. The middle one, this one will become your 180. It's like cutting it into half. Okay, you cut this into half, you get this one. This is your 90. So you figure out this first. Cannot? And of course, this is your, you can make it, you can also introduce the 3 because it's just times, right? So you just times. Okay, it didn't really, so must touch, huh? Okay. So if you want, you can write in more points, 45. This is 135 and so on lah. Okay, but that's up to you. Okay, once this is done, now you need to shift the graph up. So if you notice, this is my first step, this is my second step, and this is my third step. Now I move everything up by 5. So what I'll do is, okay, I'll draw this 5. So this one should be 8, 5, and So 0, I think, can be down somewhere here. Okay, so I'll draw this as 8. This is your axis of curve, because this will provide you the guidance. What guidance are we talking about? The guidance about where it becomes 0. These are the important points. Okay, so okay, let me just draw this out first. Okay, so this one 360. This one is 180. This one 90. And this one should be 45. This one 135. You can do the rest the same. 270. So that everything coincides very nicely. So can you see that? So it's all about manipulation. Okay. We will do one more. What if you're given okay. This one I do try 8, 13. The function is given as this minus 3 sine x over 2 plus 1. So they ask you to find the amplitude and period of fx. And part 2, sketch the graph. Okay, sketch the graph. Okay, so part 1, amplitude. Any answers?
-3.
Yeah, it's negative 3. Okay, without a doubt. But is it negative? You say negative 3 or just 3? Amplitude means what? How far is it away from what? From here to here or here to here, correct or not? So we are only talking about the absolute value. So just remember, you should not put in negative. Understand? Yeah, hope you get that point. So it's always absolute value. That's why I chose this question. And plus because it's x over 2 also lah. So what's the period? Period is what? 2 pi over b. This is for cosine and sine. For tangent is what? Period is equal to what? Pi over b. Is different. Take note, take note. If you have not been aware, please make yourself. Okay, so this is half, right? So period is half 2 pi over b. So what is b equal to? Sorry, my mistake. Sorry. The b is half. So you want to find what is the period. So that will become 4 pi. So once you reach 4 pi, then it becomes a full-fledged or full cycle of sine graph. The B, I hope you remember this, A and sine bx. So the B here is the half. Hope you understand. Okay, from here you can also quickly calculate because you're asked to draw the graph, right? So quickly just calculate on your own what is the minimum and maximum value. What's the maximum value? -3. In place of sine x over half, I take it as 1. For minimum value, I take -3, but because it's not minimum, okay, wait. There's another change here. I let you all see first. Okay. Even if I put this one, I'll still get a lower value. This one I'll get a higher value. So it's terbalik. So this is -3 plus 1 minus 2. This one will become 4. Sorry. Yeah, 3 plus 1, 4. So this is your maximum value. This is your minimum value. A trick. Why does it happen this way? Because of this. Sorry. It's because of this. Because it's inverted. The sign is no longer like that. It's like this. Can you imagine? The sign is the red color one. This is a negative sine theta, whereas this is a sine theta. Okay, Can? With this, now we can draw. Okay. Can draw a bit lower. Do I need to draw? What does the question say? Draw the full cycle or 2 pi only? Draw the full cycle. So sketch the graph for 4 pi to 0. Okay. So, okay, maybe I just draw from the start better. Oops. Okay, so this is negative. So I'll draw this out first. Negative. So since this is sine x over 2, this one will be 4 pi. This one will be 2 pi. So you will have like one full cycle within 4 pi. Usually it's within 2 pi, right? But because of this, it's being it's like expanded now. Okay, it's being stretched. Okay, hope you can see that. Okay, of course this one now what it's what -3. So it's -3, right? So the -3, this one will be your 3. Can I already inverted the graph already. By right, the sine curve should be like this. This is 3 sine x over 2. Whereas this one is -3 sine x over 2. Okay, now I need to plus 1. So I need to move this all up. So it becomes 4 and negative 2. So it's plus 1. So plus 1 is here. So this is where I'm going to have the axis of curve. Okay, the highest point now become 4. The lowest is now negative 2. Okay, and I can start drawing. So this one is the 4 pi. Here will be the 2 pi. Okay, of course, this one will be pi, 3 pi, and so on. Okay, this is your pi, 3 pi. Your highest point is 4, lowest point is negative 2. Okay? So you need to practice a bit more with this. Okay, these are still simple graphs, not that complicated. Okay, if you look at the retest, there's another way of asking. I draw for you the curve and I will ask you what is your A, B, and C, your amplitude, period, and so on. Okay. Of course, there's another type that they can give you as well, where they will ask you, they will give you two graphs and you need to find where they intersect. Okay. Again, the concepts are all the same. It's just that on the same graph, you need to draw these two graphs. Okay. To get the answer. Okay. So that is done. Okay. Simple graphs, not extensive. So you need to go and practice on your own. You can take a look at example number 16, guys. Example number 16, page number 260. That is something that you can do on your own, where you're given two graphs and then they ask you for the number of solutions. They're not asking you for the exact um, point of intersection. They're only asking you for the number of solution where they intersect. But for that, you need to know the two graphs well. Okay. Okay. Next will be principal values. Okay. So this is another small topic, but um, a lot of them get confused. So principal values. So this one is basically is for calculator usage only lah. Okay, it's being used by the calculator lah. Okay, by your scientific calculator. But we want to understand how the scientific calculator uses this. Okay, so basically for the values, right? Because if you notice for sine, this part is the same as this part here. So there's a repeat. Okay, and then followed by you have another one which is something unique, then you have something that is similar. It will give you the same values as this, correct or not? So there's a breakage. So this is the thing that we want to eliminate. We need to have a continuous cycle, so a continuous value lah. So that's where the calculator would take in this value. So if you notice, the negative part of this is over here, correct or not? So what we want to focus on, we want to focus on this part here. So this part here is continuous. Okay, and you can get both negative and positive values or ratios lah. Yeah. So this part will give you the negative, this part will give you the positive. And the range here is negative pi over 2 or negative 90 degrees pi over 2 or 90 degrees. That's for your sine. Okay, so that's what we write in terms of sine inverse of x is given as negative pi over 2 to pi over 2. Or so this is what we call as principal values lah. Is bounded by this. So likewise, for cosine also same, but for cosine is slightly more easier. Okay, for cosine, because has this value here that's being repeated again. So we just choose this portion of the graph, which is 0 to 0 to pi or 0 to 180 degrees. Okay, sine and tangent will be the same because tangent so if you notice there's a break in between the 90, right? At 90 degrees, there's a break. So we want to avoid, just hold on, there's some technical difficulties. Wait for my computer to respond. I think I just stop in between. So over here, so if you notice that at 90 degrees, there's an asymptote. So there's a break. So we want something that's continuous. So we need to get the other side. So you need just like sine. So you need this portion and this portion. So this portion falls within the minus 90 and 90 degrees, which is over here. So this is a continuous portion. So it's minus 90 to 90. So this is the same as sine. Okay, but the quadrants are different. Okay, so just take note the quadrants will be different lah. Okay, the quadrants are different. Okay, so for this one, for cosine curve, you may want to write down cosine. It is first and second quadrant because it's continuous. This one is first and fourth quadrant. Okay, because it will be continuous. It's from the negative portion to the positive portion. So same for sine. So the sine will also be first and fourth quadrant. So that's all that you need to know lah. Of course, doing it is slightly different. So we'll just do one example in case if it comes out for exam. So let's say I say find, uh, okay, let's do try it 17. Uh, find in radians the principal values of sine inverse 1 square root 3 over 2, but there's a negative here. Okay, and okay, we'll do cosine inverse half. Okay, okay, let's do another one more, just finish it off. So this is tangent inverse negative 1. Okay, so we'll do all these three. Okay, so let's look at A first. So first thing first, you should know that because it is negative, the ratio is negative ratio, and it's a sine some more. Okay, so which quadrant does it belong to? Fourth quadrant. Because for sine, it can be only 1 and 2, right? Sorry, 1 and 4. 1 or 4. First or fourth quadrant. For cosine, it is 1 or second. First or second quadrant only. Then tangent is also first or fourth quadrant. Okay, can understand this portion here. So it must be the fourth quadrant lah. Okay. So what? This is a special angle some more. Square root 3 over 2 is a special angle. So if you can recall, um, this is 2. It's 1 square root 3 here. Okay, so um, O over H. So it's sine 60 is equal to square root 3 over 2. What is sine 60? Sine 60 is sine pi over 3, correct or not? Okay, so with these values, you can already determine that based on this, okay, the principal value of sine inverse minus square root 3 over 2 is equal to pi over 3. But there's a slight difference here. You must take note of your fourth quadrant. Fourth quadrant sine is always what? Negative. Okay, are you with me? In this quadrant, sine ratio is always a negative. And here, your sine, the theta itself is also negative because it's going this way. Okay, you need some time to think through this. Okay, we'll just do another one more example. Cosine half. Since this is half, it's a positive ratio. So positive ratio, it should be in first quadrant. It should be in first quadrant. And half, again, it brings you back to the same triangle, 2, 1, square root 3. So cosine is A over H. A over H is cosine 60 again. So cosine 60 will give me, yeah, this is your A, this is your H. What is cosine 60? Pi over 3. So this is confirmed. It's in the first quadrant, okay? And since it's in the first quadrant and cosine in first quadrant, all of them, sine, cosine, tangent, okay, all are positive. First quadrant, all are positive. So you can just write the statement, principal value of cosine inverse negative half is pi over 3. Okay, one last example. Tangent inverse -1. You know, tangent must be either in first quadrant or fourth quadrant, but because it is negative, it is in the fourth quadrant. Okay, since it's in the fourth quadrant and this one is a special ratio, 1:1:45, this is square root 2. So tangent 45 degrees will give me 1. So that is pi over 4. Tangent pi over 4 will give me 1. So, but because it is in the fourth quadrant, the principal value will take on the negative answer. Value of tangent inverse -1 is negative pi over 4 because that it is in fourth quadrant. So in fourth quadrant, it will be like that. This is minus pi over 4. Okay, that's about it. Okay, nothing much. Okay, so we have covered 10.2 also. Done. So far, we have completed chapter 10 already, and it's almost 1.5 hours already. Is that enough, or do you want me to go through the chapter 11.1 and 11.2?
Yes.
So, how many of you all say yes? There's only 8 of
Me,
you all here. Huh?
me, I say yes. I
Okay,
want.
okay. So 11.1. Okay, so chapter 11.1 is an extension of 10. Okay, where we'll be talking about simple trigonometries. Okay, whatever that we have learned, but there are three main things that you must know over here. At 11.1, we are looking at identities, trigonometric identities. So simple trigo identities. Okay, so the first one basic is sine squared theta plus cosine squared theta is equal to 1. So the more you do this, the more you remember. So if I divide this by sine squared theta throughout, then I get this. Sine squared will be cotangent squared theta equal to sine is cosecant squared theta. Okay, if I divide this by um, cosine squared, okay, by cosine squared, then I get this. Okay, so these are the three main, these are first and foremost the most important. From here you get the rest. The permutations is your 2 and 3. Okay, can? So this is the main thing that you need to focus on. Um, they always like to ask you, you know, using the identities, ask you to solve or simplify. Okay, we'll do one example. Let's say you have, what is that? Okay, okay, I'm doing try to. try it too. Let's choose C. Okay, I choose C, which is secant theta over tangent theta minus tangent theta over 1 plus secant theta. Okay, so can you simplify this? That's what they ask you. So what would you do? You can have a common denominator. So if you have a common denominator, you have a tangent theta and a 1 plus secant theta. On the top, you have secant theta times 1 plus secant theta minus tangent theta times tangent theta. So it's like LCM lah. Okay. So this one you get secant squared theta plus secant theta minus tangent squared theta. Okay. You will notice that this and this, you can do something about it. So what is secant squared minus tangent squared theta? Can you look at this? So secant squared minus tangent squared is equal to 1. So this is equal to 1 plus secant theta over tangent 1 plus secant theta. Now this one I can cancel, left 1 over tangent theta, which is equal to cotangent theta. Okay, so you have to apply the formula, the three identities. Okay, I think we can do one more. It's proving. This sort of things they like to prove. So 11.1 is all about proving. Okay, let's say, okay, this time I do try it for with an example. B, a bit more difficult. Okay, so this is equal to cosecant squared x. So you're supposed to prove this. This one's proving. Of course, I think you would not choose to do from the right hand side because it's going to be a bit difficult. So I will choose from the left hand side first. So the left hand side, I'll convert this into 1 sine squared x and this one as 2 cosine x over sine x, whole thing over sine x squared plus 2 sine x cosine x plus cosine squared x. I expand everything out. Okay, you notice that this and this can do something. So you can make it into 1 plus 2 sine x cosine x. Of course, you know that 2 sine x cosine x is your sine 2x. But don't complicate the things yet. Okay, so leave it as it is. Take out what you can do is you can times this sine squared x times sine squared x so that you have a common denominator. On top, you have 1 plus 2 cosine x. Sorry, my mistake. It's, uh, it's just sine x only. because sine x times sine x is sine squared x, right? So, okay. So this is something that you need to times, okay. Then this one, if you know, actually this step is a bit redundant, but let me just work it out. This is divide by 1 plus 2 sine x cosine x. Eventually, when it becomes times, then you know that it will cancel off each other. Then you have 1 sine squared 2x, which is equal to cosecant squared x equal to RHS. Sorry, I don't have space. Then you write there as shown or proven. There you go. You're done. Okay. So far, okay, Ken? So that's all there is for 11.1. Okay. Here, 11.2 is more about solving. Okay, so we'll do that. I think that's more important as well. You'll come across this. So 11.2, solving Trigo equations. Okay, this is where all your four quadrants will come in. Okay, so let's just do an example. Okay. I think we shall start with this good example. Cosine 3x equal to negative 0.4. Solve. Can you guys please try this on your own first? I give you about 2 minutes. Just try as much as you can. Um, you're supposed to find in terms of degree, so I write for you here.
What's the domain?
Sorry,
What's the domain?
the domain is 0 to x, 0 to 360. Okay. Yeah, let me try doing this as well. Okay, guys, can you follow? Okay, let me just go through with you all. So cosine 3x equal to negative 0.4 because the first you need to find your reference angle first. So go and do the cosine inverse. 0.4, do not include the negative sign so that you get your reference angle, which is acute angle. Okay, then the next thing is because the ratio is negative, so cosine must be in second or third quadrant. Okay, and why am I doing this? Anyone can tell me why am I doing this? Plus 360 plus 720, what am I doing here?
Just adding more cycles.
Yeah, why do I get that inference that I must do more cycles? Look at this. It's 3x. What does 3x here means? That means you might have minimum 3 cycle within the thing itself, right? So you have to go 3 rounds. So you have to go 3 rounds. So final, I think the answer, okay, I'm just going to get the answer from the textbook. So these are the answers. Go and check yourself, okay? So can these are your answers. Please go and check. So this is quite simple. In fact, if they give you this, or even if they give you this, um, it's still relatively simple. Then you should know that sine x is equal to plus minus square root half. And this one will give you all 4 quadrants. Even this type is still very simple. Okay. If you get, it's bonus. Oh. Okay. First time I encounter that's a maximum. Okay, so let me just erase this off since it's maximum pages I'm allowed to come up with. Another type that they would always like to ask you is like this. Like quadratic. Okay, 3 sine x plus 2 cosine squared x equal to 0. So in this case, you must convert this to 1 minus sine squared x equal to 0. So if you notice, it will turn out to be minus 2 times 2 throughout. So 2 sine squared x minus 3 sine x minus 2 equals 0. Okay, and I should be able to get this 2 sine x plus 1 and sine x minus 2. Is it correct? 2 sine x plus 1 sine x minus 2. Yeah, correct. Okay, so this one will give me two answers, two set of answers, or sine x is equal to 2. Immediately, I know that this one will give me no solutions. Why? No solution. Anyone?
Greater than 1.
Yes, because it's out of the boundary, right? -1 to 1 is a boundary, so it's out of the boundary. So This one you can go on to find, but find your basic angle, then followed by basic angle is 30 degrees, but because it's negative, right? So it's in the second and third quadrant. Sorry, third and fourth quadrant. Third and fourth quadrant. Yeah, let me write down. I see whether if I can squeeze in some space here. So alpha is 30 degrees because it is in the third and fourth quadrant. Okay, third quadrant is 180 plus 30 is how much? 2, 10, then 330. This is your answer. This is the maximum they will ask you. Are you with me? And that's it. We have finished more or less. In a nutshell, these are the things to look out for, and this is what you should be aware of. Okay, let me save this into, yeah, save as a PDF. You can stop the recording. Yeah. Okay. So guys, that's it. Thank you for staying in for this long. Hopefully it will benefit you. I'll put this up in the Zoom later. Sorry, the YouTube later. Where's Fazal? Fazal left already. Okay. Can. Okay, that's all guys. Thank you.
Thank you.